Great, great. Thank you all for joining today. I am very excited to bring a great topic today to the We Are Developers Conference. We're going to talk about the state of GenAI and machine learning in 2025. We're going to talk about how to build with GenAI, as well as how to build GenAI. So let's jump straight into it. So a little bit about myself. So my name is Alejandro Saucedo. I am Director of Engineering, Product and Science at Zalando. I'm also board member at the ACM and AI expert at the UN. So today we're going to be talking about some really great things. We're going to start with the motivations. So why do we care about this topic? Why do we want to dive into GenAI and machine learning today? So I know that we probably don't need much convincing across the room. But I actually want to start with an annotated history of AI and going all the way back to the 1800s, to the birth of the perceptron, when kind of like brought in basic things like linear regression or the first neural network. And the reason why I want to basically go all the way back in history and in time is because I want to make an emphasis that AI is not new, right? Yes, we're hearing about it every single day. Yes, all of our family members now talk about it in dinners. But no, it's not new. Even some of the topics that you actually hear right now, things like RAG, right? Those things are concepts that come all the way from the 70s. So it is ultimately important for us to be able to go back and understand that there are best practices that we can build upon. And the important things here is that we actually see a lot of the strongly tested, high-value use cases in industry that are powering critical infrastructure in the already kind of historical things like from the 70s, right? Things like support vector machines. Those are things that actually are already in industry for a long time. And obviously, you also have the more newer and much more shiny tooling like GenAI, right? Things that cover from the deep learning birth, as well as the creation of some of the highlights like AlphaGo, etc. So today we want to highlight and touch upon more of this latter stage because there is a significant amount of potential and value. Now, at Zalando, we know that there is some opportunities there, and you may have already interacted with many of these type of services and systems. So for us, we use it for a broad range of things, traditional machine learning for things like search and recommendations, forecasting, marketing intelligence, etc., etc. But we also have several GenAI use cases, things like our fashion assistant, where you can interact and ask, what should I wear? Things like our basically machine translation. But we are also using AI in areas that maybe you wouldn't think, GenAI in areas that you wouldn't think are very obvious. Things like forecasting, where we are using foundation models for predicting demand at scale. Now, if we touch upon these use cases, we actually see that there is a reason why organizations are adopting it, right? Primarily, there is a huge adoption and a huge growth. So let's look at the market in numbers. Starting with basically the size of the market. Last time I presented on the stage, I presented a number that was around 300, 400 billion. So now we're actually on 750 billion, right? So this is only growing. And the projected growth is still to increase around at least 5x. And the number of users or active workers in the space of AI is surpassing 100 million. And this is actually growing really, really fast. So this is something that we have to take into consideration. The AI space is growing. But actually, it's important to make sure that we separate the hype from the success. And we see some organizations that are actually seeing some success in these areas. So for example, we see, as we heard just now, organizations like GitHub that are creating value for developers, creating toolings that are unlocking a lot of also business potential and business opportunity. You have organizations like Adobe that are also leveraging AI. You may have heard some of the products like Adobe Firefly, but also some of the more enterprise products like Gen Studio, which are generating huge growth, as well as other use cases within consultancies like Accenture or BCG, where they are actually estimating 3.7 billion currently and about 5 billion by 2026. So it is also important to make sure that we consider what is kind of like some of the things that are driving the value and some of the things that are actually, perhaps more on the hype areas. So with that, let's dive into some of the different kind of contrasting views that we see. So we hear a lot that Gen AI is bringing productivity to all of us as developers. But then suddenly we also hear that AI assistants aren't really making the devs more productive. But then we hear that AI is coming for our jobs. So we're not going to have any more jobs, right? Because Gen AI is going to automate us all. But then we also hear that indeed, the solutions that are coming in perhaps are not being adopted and integrated in a way that is making kind of everything more productive. So the real question here is, which one is it, right? Like, which one actually do we hear about? And this is something that we want to dive into, right? So let's talk about first some of the trends of building with Gen AI. What do we see out there that is actually, coming in? And the way that I want to cover this is basically first having a look at the past, right? So when it was super easy, you had one or two different tools to choose from in order for you to be able to generate an image or actually, interact with a chatbot. But then fast forward to today, you actually have new Gen AI tools coming up every week, right? You don't know which one to use because there's actually so much out there. So what we want to actually think about here is, from the tools that are coming in, looking from a developer perspective, how do we reason about them? And I want to talk about it from a perspective of the development funnel. So starting with basically writing code, then basically testing, Q&A, right? As ideas come in, code comes in, PRs need to be merged in order for them to be making it into production. Then you have the actual, operation and architecting. And then you have the monitoring and the debugging, right? We see a lot of the tools at the top of the funnel, right? AI copilots that are helping us write code faster. However, the humans are still in the other side, having bottlenecks with things like PRs, things like maintaining applications in production. So for us to be able to really see the productivity gains, we need to make sure that we're looking at the entire funnel and not just at the beginning of the funnel. So it's not just all about writing code. So having thought about that, let's start with some of the tools that exist within the top of the funnel. So writing code. We actually are mostly familiar with those, and you probably know some of those logos in the screen. We can see as well that actually the coverage of those tends to be higher. They stop being purely chatbots. They're agentic system that allows us to reason about those things. Now, as we go a little bit lower into the funnel, we see that for the testing and QA, there are some tools that allow you to do things like PR reviews, that allow you to do automated testing. And here we're starting to see that the maturity of those tooling starts to be on the lower end. Then we actually go one level deeper into the funnel, the architecting and operating. This is where it starts getting a little bit more nuanced, right? Where you just let an agent go crazy in your production environments, right? Would you just attach an agent to your Kubernetes cluster and let it go wild? I don't know, right? But at the end, we're starting to see some technologies coming up, but ultimately, maturity that is still required, right? Things like Harness AI or Octopus Deploy, et cetera, et cetera. And then finally, at the bottom of the funnel, now this is where you are monitoring your applications, doing proactive development, proactive delivery. We also need to make sure that we have a means to be able to maintain more applications in production. And you do have some tooling that is coming out, some interesting ones, things like Sentry-Seek or Datadog, Bits AI, M0 Assistant. But at the end, the actual coverage of these tools is still emerging, right? And for me, the shout out that I want to give in this perspective is that as we see this development funnel and as we see the investments that are happening here, we need to make sure that us as developers, we are investing in this top of the funnel. So let's all help our fellow humans, right, to be happy, right, and make sure that we're delivering more value and iterating on that front. Now, going beyond the development side, there are a broad range of tools that also exist in other domains. And from this perspective, there's a lot that is super exciting, right? Across video, music, voice, images. The other day, I was actually trying and playing around with some of the music generation services, and my mind was completely blown, right? Like, I even felt like I had some talent in music, even though, I probably don't. But it is interesting to see that these tools are still also focusing a lot on the top of the funnel for each of the respective domains, right? At the end, even in, let's say, the music industry, it's not purely just about producing and churning resources or code, right? It's all about also the QA process, the components that go in the operation beyond that, right? And when thinking about those use cases, if we basically try to build a simple taxonomy of some of those challenges and a simple summary, the first one that we mention is that top of the funnel bottleneck. We need to think about how do we actually make sure that we're investing on the bottom side? How do we make sure that we're iterating in that productivity, measuring that productivity, right? Because it's not just about how does someone feel they're more productive, right? It's about how actually more productive for the organization we are developing. And not just for 0 to 1, but also for maintenance and large-scale different components. So the second one is on the exploding vendor and service complexity. Some of you in organizations may already feel this, that you have too many API keys, that you have too many services that you're integrating to. And even if you're not a technical user, you may also be suffering from a situation where there's too many new tooling that is being introduced in your organization. 3 of the same type of applications for almost the same thing, but different names and different startups in different locations, right? So this is another thing that we're seeing in terms of the challenge. We also need to go beyond the chatbots, right? A chatbot is something that you basically would have an interaction that is potentially very low signal, high noise, right? However, what we want to make sure is that we integrate those experiences into the flows, right? That is embedded into the operational requirements as opposed to just a chatbot superficial layer on top, right? And we're seeing kind of in the top of the funnel, tooling like what we saw in the previous session that actually covers this, right? It's actually significantly much more advanced than purely just like interacting with ChatGPT or a chatbot like that. And then the most important one, and what we want to dive into in the next section, is the lack of best practices for AI systems. It seems that we have progressed a lot when it comes to the engineering of machine learning systems throughout the last decade. However, it seems that we just suddenly forgot that. And then thought that GenAI is completely different and completely new, but it's not. The same challenges that we find in traditional machine learning systems at scale are similar to the ones that we're finding with GenAI, and if anything, blown even higher into the proportion given the, higher level of abstractions that they introduce. So for that, let's actually now ask the question, how do we now go from building with GenAI to build GenAI in a best practice? And that's what we want to dive into the next section. Best practices on infrastructure, tooling, and architecture. So starting with the first concept that now actually most of you will have already kind of empathized with, is that we no longer think about machine learning models in production. We now think about not just machine learning systems, but we think about agentic systems. So with that, we don't think just about the specific component itself that has an input and an output. We actually think about the system as a whole, right? And the capabilities and components that comprise of this entire kind of like ecosystem. We also want to think not just about an input and an output. We want to think about the use case and the business outcome or the outcome that it encompasses, right? And for this, it's not just important for us to take into account when developing and architecting the system, but also when thinking about our users and the potential risks that are involved. And then ultimately, this involves third-party systems or internal data systems or areas where you need to actually fetch information or context for those agents or those machine learning components, right? And that introduces another layer of complexity, right? So we're no longer architecting models or architecting agents, we're architecting systems that are complex and non-deterministic. So now if we double click, let's look at what an agentic stack looks like. And I think this is very important if you're thinking, well, what goes behind some of those agentic systems? And to be very frank as well, the industry is still figuring it out, right? And the community is still figuring it out. It reminds me actually about MLOps about 10 years ago, where it was basically an emerging field that everybody together was trying to create concepts, components. So with the agentic stack, the things to cover is that the core potential is indeed not on the models themselves, but in the interconnected data-centric system, right? It's not just model-centric. This also includes complex orchestration across applications, infrastructure, complex data flows, and it also involves basically the traditional best practices that you would find in traditional MLOps. Now, let's talk about the different components of the stack. So you start with the agentic orchestration. This can be at the infrastructure level, it can be at the application level. You see tools like LangChain that you probably are familiar with for the application orchestration. And then you have also tools that are Kubernetes native that perform some of the orchestration at the infrastructure level, like K-Agent. You have then the interaction with other services like MCP servers. This is your gateway to other basically data sources, answers, and content and context. So with that, this is also something to consider. Like what you expose to your agents? What is the things that you want to be able to interact with? Besides that, you also need to have that sort of level of best practice protections, monitor, or best practice kind of evaluation, right? And this is something that we have seen in different situations like guardrails, moderations, things like AI judges. You have different tooling that is emerging for those type of contexts, but this is also something that is being figured out. So having kind of like another agentic system that evaluates the performance of the model, that challenges some of the answers, that checks. You then have basically the components of the orchestration itself at the machine learning infrastructure. Things like feature stores, things like training environments, fine-tuning environments that ensure reproducibility, auditability, et cetera. Then you have basically the hardware scheduling, right? Here you're dealing with complex components that you may require GPUs, TPUs, or a lot of RAM. And for this, you also have complexities that you don't have with traditional software in a way. You also have basically the observability, right? But this is not just traditional observability. This is basically agent-specific and GenAI specific, right? So for this, you have also tooling that is traditional, things like Elastic, right? Most of you probably use that within your organizations, but also others, things like LangFuse, et cetera. And even some of the traditional ones are building kind of layers on top to be able to support. And finally, a very important aspect that often is forgotten is the security, right? This is something that we're going to touch upon because these machine learning systems, these non-deterministic systems, introduce new paradigms that we need to consider. So with that, now what I want to do is I want to double-click to each of them so that we can actually learn a little bit more about some of those core components, starting with the agentic infrastructure. Now, when it comes to agents, different to maybe traditional software, although in the microservice space you do have a lot of this, you have complex, non-deterministic data flows that are required to process simple requests. And these are not just flows that are purely real-time, so let's say just a normal HTTP request. This may also be semi-real-time or batch. Right? So you have different components across your stack that need to be also kind of aligned and orchestrated, which drives different complexities. What if one component fails? What is the impact upstream? What is the impact downstream? There may be different teams involved at each of those different components. There is also the question about the domain sort of respective considerations, the scheduling, the orchestration, the data processing, the tracing that goes within those complex flows. And this is also what we were referring to as the complex hardware scheduling. So you may have things like GPUs, TPUs, higher amounts of RAM, and with that you have the orchestration that is not just dependent on basically having availability, which is what you would have with, let's say, traditional microservices, but the fact that you may want to actually make the most use of your GPU utilization. And what that basically means is that you cannot just have an application using one GPU. You may need to have multiple applications bundling the use of that GPU, right? So those are complex considerations that you need to take into account. Now, the second thing that I want us to remind ourselves is the topic of boring data. I know that in a talk about GenAI, that's not the most exciting part, but it's still one of the more important ones. So when it comes to the boring data, the archetypal concept of garbage in, garbage out is still true today. That means that we need to make sure that we're investing in our data because great data will help us to make great agentic systems, and same with the opposite. This also requires the new protocols that are coming up, right? So driving standardization on best practice and interoperability. We are not yet consolidated in the protocols. We, of course, now talk about MCP, the Model Context Protocol, as if it was the one that is already kind of like fully adopted. But we have to remember that it's still relatively new, and there are many other protocols, like the A to A or the A to N protocols. And at the end, when basically investing in our quote-unquote boring data, this is what actually gets that sort of advantage. This is what gets us to be able to deliver faster, that gets us to be able to develop evals that are sound, that are robust, and that allow us to actually remove headaches when it comes to productionization of these systems. Then moving to security, right? And this is another topic that I know is often brushed off, but it's actually very interesting because in the era of agentic AI, in the era of machine learning, security is king, right? And we actually see that there are emerging vulnerabilities that are coming out. So we've actually been working with the OWASP organization, the ones that actually set the OWASP top 10, to be able to define a taxonomy of types of vulnerabilities and exploits with agents. And what is very interesting is that you have types of vulnerabilities that you would not think about when it comes to traditional microservices. Things like data poisoning, so basically scraping data that may be actually malicious, and memory poisoning, remote code execution, right? If you actually are plugging your agents to, I don't know, production services, right? That already is a red flag. Or at least not with considerations. Identity spoofing, multi-agent chain exploits, cascading hallucinations, etc., etc. So I recommend you to actually dive a little bit deeper because this area is not just important, but it's also emerging, right? So we're trying to define it as it evolves. And then one of the final ones to cover is on the monitoring side. So there are some paradigms for observability that you need to take into consideration. So things like normal service performance, you also need to know what is your let's say, memory consumption, CPU consumption. You need to know if there's a memory leak, sort of like similar to how you have it in your traditional microservices. But you also need to introduce GenAI-specific monitoring, things like LLM performance, metrics, evals, online and offline evaluation of your systems, of your models. You also need to think about explainability, right? You're delving into black box systems. And now you need to be able to understand where something was provided to a user. Why was that not provided, right? And there are some advances in explainability that allows you to be able to open the black box. And then finally, things like outlier detection, drift detection, right? This is something that also enables you to understand, has my model drifted? Is my agent in need for retraining? Do I need to refine tune my models, right? And then the final topic that I want to also not forget is that when it comes to AI, and also obviously GenAI, we are also getting closer to the use cases themselves. And responsible AI becomes very important, very relevant. The reason why is because there are challenges like things like algorithmic bias, right? Things like undesired outcomes that you may not even be able to predict unless you have the relevant domain experts and the human intervention throughout. And what this is needed is making sure that within your software libraries, your platforms, your systems that you're developing, you have a way to be able to align into the higher level industry standards or company standards, guidelines that you can actually create that are then aligned to those higher level principles from that perspective so that you can actually have aligned North Stars, whether it is explainability, interpretability, fairness, equity, etc., etc. So this connection is important as it doesn't matter how many discussions on principles you have if the infrastructure, if the systems don't align and map to those principles by design, you are not going to be able to achieve those components. Now with that, there was a lot of content and there was a lot of things to digest. I want to be able to wrap this up with a couple of closing thoughts before we actually finish off. The first one is that when it comes to machine learning and GenAI maturity, a lot of the times we think about it as a linear curve, right? We actually go from an analytical capability to a predictive capability to an autonomous system, right? However, what we are starting to see is that it's no longer a specific linear path. It's more about how do you make sure that you're able to continuously achieve those capabilities in different parts of your stack, different parts of your domains, different parts of your skills, and it's how fast are you able to then iterate and get there, right? So the way that we think about it as well is this time to value, right? Whether it's from concept to GenAI system or whether it's to idea to be able to creation. And there is a huge opportunity to accelerate this by ensuring that you have great data, great integrations. There is now kind of this concept that is coming out, being called this context engineering, to think about how to make the most productivity to those type of systems. I also want to talk about the roles and responsibilities that are emerging, right? throughout the emergence of AI, we have seen a lot of new roles that have come up, right? Obviously, we know the traditional ones like a data engineer, a data scientist, a DevOps engineer. However, when it comes to the typical kind of new roles, things like the machine learning engineer or the MLOps engineer, we are now seeing even new emerging roles coming up around that, right? So things like things like the AI engineer, right? So here we're actually seeing some emerging kind of like new roles coming up, and we need to define what exactly they do, what exactly they mean. So the last thing that I want to close with is this point on talking about all of the challenges that exist within the world, right? So if you think about all of the problems in the world and the relevant solutions, a subset of those are actually going to be software solutions. A smaller subset of that are going to be AI and machine learning solutions. And then if you really zoom in, the very tiny bit over there is GenAI solutions, right? So the key message here is, when you're running around with a hammer, everything may actually look like a nail, and it doesn't have to. Sometimes you don't need GenAI to solve the problem. Sometimes it actually takes less time for you to just write that line of code instead of actually, iterating and prompting until everything is done. So I'll leave you with a couple of, further deep dives. So if you actually want to have a look at any of the deeper contexts, you can find the slides at the top right. So any feedback as well, feel free to send it over. So with that, I want to thank you all for your time, and I wish you a great We Are Developers conference. Thank you all.